and line surface volume. Okay, so line surface volume integrals through Stokes theorem and Gauss divergence theorem. Simple. So now we understood what is a vector field, what is a scalar field. Okay, so mostly we will talk much about vector field because where you have both magnitude as well as direction. Okay, so what is divergence? What is grade? That you will get it for short answers. And Stokes theorem and Gauss divergence theorem, you will get it for long answers. Okay, if a line surface volume integral question, you may get it for essay or short. They may ask you to write, explain, define line and surface or surface and volume integrals. So it is completely interlinked with one topic to the another topic. So if you understand what is divergence of a vector field, then you will understand what is gradient of a scalar field, what's curl of a vector field. So we are talking all the time about a vector field. Okay, so here we have the flux lines. Here we are familiar with the flux lines. Do you know what is flux lines of a bar magnet? Anybody? What is a flux line? Which gives the direction of the magnetic intensity at that point. Moreover, the number of lines passing through the unit area of the surface perpendicular to the direction is called a magnetic flux. So what is a flux? Let it be electric flux or magnetic flux. Let it be. What is a flux? What do you mean by flux? Tell me. Anybody can answer. Just don't search in Google and don't tell me. I know you people are very smart, but just try to answer if you have any idea. If you're taking too much of pause and then you answer means I can find out that you have just Googled it and you're telling me. Then and there, if you're telling means you are trying to tell me. If you don't know, it's fine. Okay, so what is a flux is nothing but a flux is a straight line. Okay, is a straight line. Flux is nothing but straight line. So the energy whenever it is transmitting, the fluxes is nothing but all flowing at a time. Flux is a single line with an arrow, like a arrow. Okay, all the fluxes will be flowing at a time. Is nothing but a flux. Okay, got it?
Ma'am,
Yeah.
Yes, ma'am.
Uh,
flux
Yes,
can
ma'am. Yes.
constantly changes, ma'am.
flux is
Can constantly changes.
constantly changes, yes. But what is
Yes.
a flux? Flux is what is the shape of the flux? I'm asking. You googled it, no? I
No,
understood.
ma'am. No,
Hmm.
ma'am.
Then how do you know that constantly changes?
Ma'am,
How you think?
here
Hmm.
in second point, the heat will flowing in different directions. So through that, I have got
Huh.
an idea, ma'am.
Okay. Flux line. See, point O. A flux line gives the direction of a magnetic intensity at that point. See, how the shape. What I mean is how it looks. Okay. The flux
Somewhat
is a
in circular shape,
what?
somewhat like circular shape, like current is
No,
flowing.
no. Circular shape. So if I'm taking a circle, for example, if I'm taking an iron sheet, which I made it as a circle shape. So if I'm giving some external force, okay, the energy will be passed. No, the current will be passed. How it will be passing? So we
That will
have
be in the
given,
straight line.
huh? Sorry.
That will be in the straight line.
Yeah, that's what I want. This is the answer. Okay, if I'm taking a molecule, water molecule or gas molecule, whatever, it does not have a proper flow. Means it does not flow one by one.
Correct.
The energy will be transmitted every in gas molecule or water molecule or if you're taking a flow of a charge. But in vector field, what happens? Why we are talking about a flux means it goes in a single line. The energy will be transmitted from one place to another place. Understand? Electrons are there, but electrons will not travel. The energy will be transferred. Understand? Once if I'm giving some external force to an electron starts vibrating and re-radiating. Means the energy will be transmitted in a way, but here we are not going that further. So I'm talking about your third unit, but here we are talking about a line. So how this will flow? If I'm taking a complete square sheet, let me give you an example. If I'm taking a square sheet, it's an iron sheet. If I'm giving some external force to that sheet, how the energy will be transmitted? One by one, it will be go in a order. However it want, it does not go like a gas molecule or a water molecule. It goes in a proper way. That might be circular shape, that might be square shape, that might be any shape, triangle shape. It goes like an arrow, one by one, like ants. How it ant will go one after the other. Like that, the flux lines are that might be electric field or magnetic field, whatever field we take, it has a proper flow of direction. So why I'm stressing this because if you understand this topic, other topics are so simple. So why I'm concentrating, focusing much on the flux? Because the energy, whatever we are giving some external force to there, so all will be transmitting accordingly, equilibrium. We call it as equilibrium. Equally it will be traveling. Clear? So this is about this flux, how that works, how the flow of the heat from hotter phase to colder phase. That is, we call it as a scalar. So flowing from the heat from hotter to colder or to colder to hotter, whatever it is flowing, that is a scalar field. But here the heat will be flowing in different directions in different parts of the block. This heat flows in the vector field. So in vector field also we can find it out. But mostly when we talk about water or gas, it will be in because the temperature can be increased or decreased. Then when coming to the current can be increased or decreased. Hello, I'm cool. I have shoot any question.
Yes, madam. Can you
Huh?
repeat?
What I'm asking, if I'm taking a gas molecule or water molecule, I can increase the temperature and decrease. Yes or no?
Yeah.
Yes, ma'am.
But coming to the current, okay. Can I increase the current? Can I decrease the current?
No, ma'am.
No, ma'am. You can increase the current, ma'am.
No, it will be constant. Voltage
Current
will
is
be
constant.
constant.
Yes.
Voltage will be constant. Current will be continuously flowing.
Yes, ma'am.
You can change the voltage, but you can't increase and decrease.
Yes, ma'am.
5 volts you have taken, you can make it to 10 volts, 20 volts, 30 volts. You can change, but you can't play with the voltage, no?
Yes, ma'am.
Okay, you want a constant current. How the current is coming? Continuously, constantly, you are able to see the laptop or mobile phone, whatever the current which we are using. It is not fluctuating, right?
Yes, ma'am.
Continuously, you are getting how all the electrons are going in continuous process and it is taking only positive electrons and you are getting the light. You're getting the fan,
Ma'am,
whatever the
but
gadgets.
the units are increasing now, ma'am.
Huh? Differs,
Units.
no?
Yes, ma'am.
See, for different electronic gadgets, the voltage will be differs.
Yes, ma'am.
High voltage cannot be used, no?
Yes, ma'am.
So for refrigerators and TVs, you have a voltage stabilizer. Why?
To
If you
control the current, ma'am.
yes,
Change.
when it suddenly gets high voltage or low voltage, what it does? It does not damage the whole system.
Yes, ma'am.
Okay, understood? So
Yes,
Yes,
ma'am.
that
ma'am.
that is we will talk in last unit. Okay. So here, let us see, this is the basics. So why we are going to talk about this vector or this flux? Because all the current will be going in a one single line. So equilibrium means equally it will be producing one by one continuously. Okay, now we will discuss what is divergence of a vector field. Grad del and divergence of a vector field. The operator del can be involved in the multiplication with a vector. The scalar or dot of the product operator del with a vector del A, that is del dot A is called, we call it as
Diverse.
divergence. Divergence. See, diverging, if I'm taking a S shape, the flow of the electrons will be growing one by one according to the S shape. That might be any shape. Got it? It can diverge, but it flows in an arrow only. Got it? You are able to understand?
Yes, ma'am.
Okay, so here we are seeing divergence, we will see the curve, we will see different lines, line surface, surface integral, volume integral, we'll see. Okay. So this amount of the flux, the divergence is a scalar quantity because it represents simply the amount of flux. Flux means we know it goes in one direction. So for example, if I'm taking A is a vector function, A is a vector function differentiable at each point of x, y, z, the region of a space. If I'm taking a space, A is a vector and x, y, z are the coordinates. Okay. In a region of space, what can be written by divergence of x? See, physics is an imagination. As I told you in the last class, we need to imagine and we need to use a mathematical to simplify it to get the output. So without mathematics, there will be no simplification. If there is no simplification, what you do? You have to calculate one by one, continuously. There will be no end. So we need to simplify. So we have taken a del operation for the A vector. So with a differential each point of x, y, z, what I'm doing, I do by dou x plus j dou by dou y plus k dou by dou z of I of ax plus j a of y plus k of az. Okay. So by doing this, we get dou x by dou x plus dou a by dou y plus dou az by, sorry, this will be z. This is printing mistake. That is d dou az by dou z. That will be the equation 1. So the divergence of A, that is del dot A, can be written as dou x by dou x, dou ay by dou y plus dou az by dou z. Again, here also spelling mistake. Correct it. So these expressions of the divergence is Cartesian coordinates. Yes, this is the point where I want to discuss. Cartesian coordinates. What is mean by Cartesian coordinates is nothing but, okay. So let me do this you need to understand. Okay. Let me draw. Take this. Okay.
Ma'am.
Okay. X axis, Y axis. So this will be the X. Okay. This will be the Z. And this will be the Y. Clear? So I just want to tell you what is the Cartesian coordinates because this will be continuously repeated till you complete your degree. Okay. See, listen. I'm taking a single electron over here. I just want to find for x-axis. This is an electron. So when an external force falls on this electron, I've drawn very bad. It's a wave. Okay. So what happens? The electron starts vibrating and re-radiating and hits the another electron. Clear? So this energy is transmitted from one electron to the another electron. In which way it is going? In a flux. That is in a straight line. Okay. I have taken a one single electron and I'm telling. So it might be so many electrons here, continuously, dot, dot, dot. Okay, understand? Clear? So what happens? This energy is transmitted to this electron, this electron, this electron continuously. Happens. So if I'm able to find for one single force, that is one single electron, where I can find x-axis, y-axis, and z-axis for one single electron. Okay, so if I'm able to find one single electron, I can find for n number of electrons. So how I'm finding what is the Cartesian coordinates? Coordinates is nothing but x-axis, y-axis, and z-axis. So when x is 1, y and z will be 0. When y is 1, x and z will become 0. Y will be 1. When z is 1, xy will be 0 and z will be 1. That is nothing but Cartesian coordinates. I can write a Cartesian coordinates for the whole flow of the electrons. For x-axis, for y-axis, and z-axis. Clear? Is that clear? Cartesian coordinates. Understood?
Yes, ma'am.
Okay.
Yes, ma'am.
So Cartesian coordinates is coordinating because one electron to the another electron, it keeps on flowing. The current is coming continuously. So I just want to find. So manually, if I want to find, I can find the coordinates for x-axis, y-axis, and z-axis. For one single electron, if I'm able to find, I can find for n number of electrons. So manually also I can do. But because of this Cartesian coordinates, the simplification, I can manually also, I can do by one electron to another electron, front to back, if I'm taking a cube. Okay, how I want to find upside down, back, front, the image, whatever it is showing the electrons, I can find the full sides of the coordinates. Okay, so that's why this quantity has important application in hydrodynamics and electricity. When we talk about electricity, how this electric current is flowing, there we are going to use this application. Okay, so when we switch off the ceiling fan in a room, the air from the fan will be made to flow outwards from the fan. This makes the air flow diverging. We can think of divergence of flow field. They have given a beautiful example. Okay. So derivation of this expression. So where we are going to find the XYZ vectors. So let vector A represents the velocity of the fluid at center C with the components AX, AY, and AZ along the three axes respectively. Let dou AX by dou X represents the rate of change of AX. Dou A by dou Y. So same, simple. If we are able to find for X, we can find for Y and Z. So let us see this diagram. Similarly, the magnitude at the center N of phase. Mute, no? Somebody's talking. Mute. You please mute. I don't want any distraction while teaching the class. So x-axis, y-axis, and z-axis. See. So if I'm taking this, what this is called? Tell me. Shape of this.
Rectangle,
Huh?
square, cube.
Okay. So the
This is cuboid.
yes, cuboid. Okay. See, if I'm taking a electron over here, okay, I can find here, here, everywhere. No? Everywhere I can find. So front, back, down, up, all the axes. I can find the coordinates from this side, this side, this side, this side, everywhere. Inside, back, inside also. So if I am able to find the axis, see here they have given a vector of AX, AY, and AZ. So I can find this is what I have explained you. Okay. So with this help of the finding of so negative also will be there, which is this will be positive, this will be negative. So AX minus half dou X by dou X of dx, AX plus half dou AX by. So if I want to find the x-axis coordinates, this will be positive, this will be negative, no? This will be negative. Yes or no? So this, if I'm finding the x-axis of this way, if I'm finding the coordinates, this will be positive. This becomes negative. I'll show you in the next class how we can find the coordinates. I've done it. I'll show you in the next class. Okay. Now I can't search and I can't show you. So I've done the coordinate system, how this x, y, z coordinates can be written manually. So the negative sign is taken because n is towards left of the C. This is left hand will be negative, right hand will be positive. With that, you can find the total flux. Leaving what? Flux is nothing but electron to electron, electron to electron, which is flowing. That might be x-axis, y-axis, and z-axis. With that, you can find dou x by dou x plus dou a by dou y, dou az by dou z. That is of dou x dot dou y dot dou z. So here you can find the divergence of A. Flux divergence per unit volume and divergence of A. That is, therefore, divergence of A is nothing but dou x by dou x and dou A by dou y plus dou az by dou z. Will be the complete divergence of the A. You have any doubt? You can solve it so simple. There is nothing complicated. They have not taken something else and they are not done. So they have taken x-axis, y-axis, and z-axis. They have taken a vector that is A, and we are going to differentiate with that, and we are going to get the divergence of A. Try to do it, simplify it. If you have any doubts, you can ask me in the next class. Okay. Next is significance of divergence. So what is significance? If A represents a velocity of a fluid, that is liquid or a gas, then divergence A gives the rate of flow of the fluid at that point per unit volume. So if divergence A is positive, at that point, then either the fluid is undergoing expansion or the point itself is a source of a fluid. Okay. Similarly, a negative value of the divergence means that either the fluid is undergoing contraction or the point serves as a sinker. So we can find for the significance of divergence, we can find for the liquid or a gas, the fluid. So here we can find for liquid or a gas, it can be increased or it can be decreased, positive and negative. So negative is nothing but which is sinking. Positive is nothing but which is expanding. Clear? So for that also we can find the divergence of A, where you are taking divergence A is nothing but del A and I of Ux plus J of Y plus K of Z. That is equal to equal. So here you can find the divergence of A by taking the values of here they have given the divergence how we can calculate. Okay, you can take the values of 1, -2 and 3. So simplify it in this equation, you'll get a divergence of A is -1. So next is gradient of a scalar. Indefinite answer question for 5 minutes. What is grad? Gradient. Gradient is nothing but which is having the differential operator which can be associated with a vector field with that of a scalar field. Okay. So gradient of a scalar function we call it as a pi. Okay, pi is a vector whose magnitude at any point is equal to the maximum rate of change of scalar function. With respect to space, visible has got the directions of the change. So wherever it is visible, the direction can be changed. So for example, if you are taking the intensity of the electric field. So intensity means what? Intensity means what? Which is going depth. So when a light falls on an electron, we call it as intensity. So how much intensity it is taking to flow the light inside that material? That is what is intensity of the electric field. So a vector quantity is a gradient of a potential, that is V. Scalar quantity with a negative sign, that is E is equals to minus grad of V, called as negative sign. Indicates that the direction of the field intensity is opposite to the direction of increase of the potential. For example, if I'm taking an electric field, okay, I want to find an electric field. How I can find? Either I connect forward bias current or reverse bias current. Yes or no? To get a forward means if I'm viewing a voltage to a diode or any material or a iron sheet, what happens? It has both forward current and negative current. Forward means which having a PN junction diode, for example, positive to positive, negative to the negative. If I'm connecting positive to the positive, negative to the negative, the current will be flowing nicely. There will be no disturbance. Okay, but if I'm connecting that into reverse, positive connected by negative, negative is connected by positive. So what happens? Only the leakage current will be produced. What is meant by the leakage current is nothing but if I'm taking holes and electrons in a PN junction diode, when I'm connecting an external force that is forward or reverse, in majority charge carriers in P, you have holes. In majority charge carriers of N type, that is electrons, you have N type you have electrons. Okay, minority charge carriers in P type you have electrons. In N type, minority charge carriers are holes. You are getting? Everybody understanding? Okay, I'm just explaining you how this electric field can be used. Why we are
Yes, sir.
calling it as negative. Okay, why we are calling it as negative. So when this flow of the charges are taking place, what happens when reverse current is being connected? Only minority charge carriers will be connected. There will be no proper flow of the current, only reverse current, that is leakage current. So we can find positive as well as we can find negative. This negative current is also going to be useful in some cases. Clear?
Yeah.
Okay. Done. So this is about gradient of a scalar field. Here we are going to take the Cartesian coordinates in space. Space means we need to imagine. We need to imagine and cuboid if we are taking where we can find all the directions. That might be back, front, as I told you. Cartesian coordinates can be found in space, that is dou x by dou x, dou x by dou y, dou x by dou z with the partial derivations along. Okay, partial derivatives along the three perpendicular axes. What is the axis? X axis, y axis, z axis. Now the gradient of the scalar function x can be defined as grad of x, that is I of dou x by dou x, j of dou x by dou y, k of dou x by dou z. So we have given the name. Okay, S is nothing but space. So for that, say space, we have added grad S, that is becoming where del dot S is becoming I of dou x by dou x, dou j of dou by dou y, plus k of dou by dou z, generally called del or del operator. Now we know what is divergence. Now we know what is grad. Okay. So next is physical interpretations of grads. So physical interpretations are nothing but, so let us take the scalar field can be mapped out by surface of level surface. Two such surfaces very close to each other. So if we are taking a two surfaces, for example, here one surface is there on the surface. If we want to find the surfaces for S1 and S2 respectively, so we are able to find the coordinates of the X, Y, Z. Okay, so we are able to write for values for S as well as R. So if I'm taking two surfaces S1 and S2, so let R be R and R plus dr be the position coordinates of P and R respectively with respect at any arbitrary origin. Then PR is becoming D of R. So if coordinates of pair, that is X, Y, Z and R are X plus dx, comma, Y plus dy plus, sorry, Z plus dy, dz it becomes wrong here. Then we can write dr is equals to I dx plus j dy plus k dz. Okay, as a continuous scalar functions at p of x, y, z as values. So we are just finding for two surfaces and we are deriving the equation to simplify it. So here you can find ds is equals to ds by dx not dx plus y plus z. Okay, this equation may also be written as in this way also we can write. So ds is equals to I, so ds by dx, y and z. For I, dx plus j divided as k dz. That is del dot s bar dot dr. So here we are going to find the vector of that. So here in fact, two space s and s plus ds. We have taken two. Okay, two surfaces are taken. This can be one surface. This can be another surface. Okay. So where I can find the surfaces S1 and S2, where I have taken S and S plus ds. Next also I can calculate, no? Next also. If I am able to calculate for this and this, I can find for n number of surfaces. Clear? So I'm able to find the coordinates between this and this, S and S plus ds. Clear? So in this way, we can find the lines in the level surface of S1. Then ds is equals to 0. That is del S dot dr equals to, showing here that the vector del bar is nothing but a vector. S is normal to the surface. Whenever it is bar is there means what? It is having both magnitude. Vector is nothing but bar, single bar. Means both magnitude as well as direction.
Direction.
Okay, it's normal to the surface of S1, that is, the surface S is constant. If dx denotes the divergence along the normal from point B to the surface S2, we may write this as dx is equal to pq, that is equal to s cos theta, that is equal to n cap, that is dot ds. So this is n cap is a unit vector normal to the surface of S1 and p. and at P that is along PQ. Okay. So this we can write it along with the P and P2Q along PQ we can write. This will be the equation, combining equations both we may write ds that is del dot s equals to this. So here we are going to get the grad s that is what del dot s is nothing but ds by dx dot n cap. So defining of grad s. So what is defining of the grad s is nothing but just read this ds by dx dot n cap is equals to minus grad of s. So next is curl of a vector. See, if I'm able to find for any surface, I can find for a curl, right? That might mean circle, that might mean different shapes. So here, now you understood the concept, how we can find a vector field. I can take a curl of a vector field, I can take a line of a vector field, I can take a square of a vector field, I can take a rectangle shape, whatever. So curl of a vector. So here, you can find for the axis, x-axis, y-axis, and z-axis, where you can find the physical significance of the curl of a vector. We may be understood by considering the rotation of a rigid body. So, rigid body means which does not move. Okay, which rotates over there only. Because we need to understand this because the current which is flowing towards a rigid body which does not flow from one place to another place, it should happen there and then. Okay, so rigid body around axis, if a rigid body is rotating with the angular velocity, okay, to that omega is equals to angular velocity, that is 1 by 2 curl of V when V is a linear velocity. Okay, this is the equation for curl of a vector and examples. Consider the velocity. Hello? Hello? Just go through it. It will be simple. There will be nothing complication of deriving this. So you can find this curl of a vector. You have to simplify it because every time I can't teach you step by step. You need to do little hard work from your end also. If you have any doubts, you can come back to me. So we can write different types of a vector fields. So let me tell you what is a one example. So consider the velocity field of water flowing in a river. If there is a deep pot in the bed of river, then the velocity of water flowing has rotational components around that point. Consequently, the water will rapidly if a swimmer gets into this region. He starts rotating rapidly and becomes very difficult for him to get out of the region. So curl of a vector, if it continuously happening in that body itself. So when a rigid body is in motion, then the curl of its linear velocity at any point gives twice its angular velocity in magnitude different direction. Okay. So there's different types of vector fields we have. We just go through this simple. Simple things I'm just where you can understand, you can read and you can write it down, no problem. I just want to go little further because we have only 20 minutes left over. So I want to complete this syllabus. First unit. So now I want to talk about line, surface, and volume integral. Very important. Where integrations of the vector. So what is a line vector? So I have taken a vector, okay, that is A bar, okay, which is flowing from A to B. So line, surface, and volume. Okay, so line. Okay, I have taken a line for this. I just want to find first simple. First, I want to do the integration for a one single line integral. You need to focus, everybody focus and listen carefully. So if I'm able to find for one single line, taking A to B, okay, with a vector A and with an angle theta and with a dl, be an element of the length of the curve from A to B. Okay, that I am representing it as an R. So let us see the integration of vector along a curve is called its line integral. For one single line, I am finding. As shown in the figure, let A be the curve drawn between 2 points A and B in a vector field. Let dl be an element of length along the curve that is AB and AB at R. Suppose R is a vector at R making an angle, the direction of dl, then what we can write? R dot dl is equals to R dot dl cos theta, that equals to dl r of cos theta. Okay, for one single line, I'm just finding the integration. Okay, shows that the volume of R dot dl at any point of the curve is equal to the product of small element dl and the component r cos theta along the direction of the dl. So I'm just finding for one single line of the direction. Okay, so then the value of r dot dl of the component curve, that is AB, can be obtained by integrating equation. So where we have taken this equation, from here only, from the line only we have taken. Okay, R dot dl, that is equals to R dot dl cos theta, it is becoming. So that is nothing but dl r cos theta. So from that equation, we are able to write the integration of that. So here, hence what it becomes, integration A to B, because A to B is a line. That is nothing but R dot dl, that is equals to A to B dl of R cos theta. Is that clear till here?
Yes, ma'am.
Okay. So here what we are finding, we are simplifying for one single line. For one single line, if I am able to find, I can find for the surface, I can find for the volume. So integral of A to B R dot dl is defined as a line integral of A along the curve of AB. See, of the line A along with the AB. This is line integral, simple, nothing complicated. Next comes calculation of work done by varying force of the body using the line integral. Okay, you need with this, or you till here it is fine. Okay, this is about the line integral. So now next comes surface integral. Surface, now take it a surface. Okay, in that surface, I just want to find the angle over here. Okay, so if a surface area of S,
Madam, just a minute, please.
tell me,
Madam, what is the usage of this line integral?
line integral. See, I'm talking about an electron, right? One electron I'm taking. A single
Yeah.
electron I'm taking. So how this flow of the charge is there for one single electron? So to find out that one single electron, I'm able to calculate with the integration by taking from A to B. Okay, I've
Okay.
just simplified it and I am able to find for a one single line. X-axis, Y-axis, Z-axis is there, no? So for one single line, I'm able to find. Then I'm able to find for the surface. I've taken a surface. See, I've taken one iron sheet. For example, I've taken a one iron sheet. I want to find the flow of the charge. Here, everywhere I want to find. So to find out the whole sheet, I need to find first for one single area, no? So that is the area which I have taken. One single area I have taken. If I'm able to calculate for one single area, I can find for the whole sheet, whole surface, whole volume. Got it?
Got it.
Okay. So here I'm taking a single surface area. In that surface, I'm taking a one single, pointing out some position of this, and I'm able to find out the area of the ds. Here I've taken this is a surface. In that surface, I'm taking a area. That is ds I'm taking. Okay, consider, and if A is a vector, where you can find both magnitude as well as direction. So okay, theta, here where you can find the angle theta with a unit positive outwards, where I'm able to find for the outwards. Then the integral over the surface. First I've taken for one single line, then I'm able to find for the surface. So here what happens? Double integration happens. Double integration A dot ds equals to double integration of A dot n dot ds. That is equals to integration of A cos theta ds. So it is defined as a surface integral or total flux of A through the whole surfaces. So if I'm able to find for single surface area of this, I'm able to find for the whole surface. Next comes under volume. So double integration of S, we call it as Single line is nothing but single integration, A to B. Surface is nothing but double integration. Okay, where we are able to find for the whole area of that. So double integration of S, A dot ds represents the rate of flow of fluid through the surface S. Understand? Anybody, any doubt? Please tell me here. I can clarify more. If it is clear, we'll go further. I'll go to volume integration. Respond. Somebody. Hello.
Ma'am.
Yeah, clear?
Yeah.
Where you are having doubt? Tell me quickly. We don't have much time. Surface integral or line integral, where? See, I'll just tell you the concept. You first understand the concept. Concept is more important. Then you can understand these equations very easily. Okay, I have taken a one surface, one wall. For example, I have taken this sheet. Okay, I want to find one electron over here. See, one electron is over here. I want to find this electron, how energy is being transmitted. So to find out for the whole sheet, what I need to do, first of all, what I've done, the experimentally or the by thinking. So when they are inventing, they can't find for the whole, no?
Yes, ma'am.
If they are able to simplify for one single electron, they can find for the n number of electrons. Okay, I've taken a one single electron. Okay, one single electron. For this, what I've done, I've taken this electron. I take out this electron and I have simplified it for the line. For if the force of the line, for example, the energy is being transmitting, the light is falling on this. Okay. So this electron starts vibrating and radiating and telling. How to calculate that? I'm telling you the concept, but you need some calculation part, right?
Yes, ma'am.
So I'm simplifying it by taking for one single integration. That is one line integration. Then I've done with this. Then I've made this sheet into half. Half sheet I've taken. Because it is lengthy, no? To calculate for this whole. I've taken a half sheet. Then I've done a surface for this. So if I'm able to find out the surface of this and I'm able to calculate the complete volume is there. What I'm given mathematically this single line integration. If I'm taking for this whole surface, I'm taking it as a surface integral. If I'm taking for this complete, I'm taking it as a volume integral. Got it?
Yes,
So
ma'am.
I'm doing it in a mathematical way to simplify. If I'm unable to find for one single electron, how could I find? I understood the concept. Understood the concept. Yes, electron starts vibrating and radiating, the energy is being transmitted. How? I want the calculation. So whole current or the energy cannot be supplied for the whole appliances. No, all the appliances the energy will be transmitted the same. No, it differs. For light, some other power will be there. For fan, some other capacitor will be there. Capacitors will change, no?
Yes, ma'am.
For your phone, the charging power, the battery power will be differs from one phone to other phone. One laptop to another laptop, backup, whatever we take. So to find out that electronics we are using switching on and off. But the back end of the depth of the topics, whatever we are studying in the physics, that was invented. They have imagined and they have understood the concept of flow of the charge and the electrons. Then they have invented the slides, whatever we are using. Now we are studying so simply and we are understanding. We are unable to understand what they have invented. Got it? So in this way, one single line we are able to find. Then I am able to find for the surface. You need to understand how you have to go back to their brain level. They have simplified the small, taking one single part. Next surface. Then they have done step by step. Then they have, yeah, if this is been successful, yes, the current is flowing in single line also, we are able to find the integration of that because mathematically, without using mathematical calculations, we can't. See, I'm telling you, this is a vector, this line is flowing in this way, the current is flowing from here to here, I'm just telling you. But I want to calculate how much current it is taking place to flow from here to here, from here to
Mm.
here. Understood? So
Yes,
for
ma'am.
that, line, surface and volume. So surface we are doing it as a, for the whole surface I've taken. So double integrate to simplify it. The next will be the volume. So volume means completely. So I'm taking triple integration of A dot V, A dot dV. So that is x-axis, y-axis, and z-axis. Where I've taken a cube, where I can find for this way, this way, this way, back, front, everywhere, single point to point, point to point, point to point, I can calculate the whole. So this is a volume where I am able to find the Cartesian coordinates for one single electron. Got it?
Yes,
If I'm
ma'am.
able to find for one single electron, I can simplify it for n number of electrons. If I'm able to find for volume, I can find for the bulk. Clear? The above three integrals are useful in solving many of the physical problems. These are the basic line, surface, and volume integral. By deriving all this, simplified it so simply. Concept understood. Yes. But mathematically, if I'm not able to derive this, I'm unable to get the power, get the calculation. Unable to do. Okay.
Okay.
So this is about the line, surface, and volume, and damn sure portion. Definitely you'll get it. Next is Stokes theorem and Stokes theorem. So Stokes theorem is very simple. What is Stokes theorem? So you need to learn the statement also. The theorem says a line integral of a vector field A around a closed curve is equal to the surface integral of the curve of that field takes over the surfaces surrounded by the closed curve. See the diagram? I've taken a surface. Okay. So I've given some lines. So to simplify that, I've taken a single one surface. So in this complete circle, I've made find out one electron to another, another to another. So what I'm doing, I'm taking a one single surface. So that is nothing but double integration curl A dot ds is equals to integration of A dot d. Here ds is a very small element of area of the surface. So here I'm taking a single surface, and if I'm able to calculate for this bonding of the C of the surface, I'm able to find the whole surface. Understanding? I'm telling you the electrons are continuously flowing. How that is flowing, how to calculate, how this energy is transmitted from one electron to the another electron. So how this can be transmitted this way, that way. All the ways it can transmit, no? That can be negative, positive, up and down. Okay. So obviously, theorem finds which surface integral of the curve of the vector field A is converted to the line integral of the vector field and vice versa. So here, the Stokes theorem says that consider surfaces, consider surface S with a C as its bonding and it is enclosed in a vector field A. Okay, vector field A, where you have both magnitude as well as direction. As shown in the figure, the boundaries of the surfaces is closed curve with a PQ and R. PQ and R flowing in this way. Okay, the line integral A around the curve, that is PQR, traced counterclockwise is integration. This is a flux, sorry, this is a flux. The symbol of the flux is this. So flux means many will be there. So symbol of the flux of A dot dr. dr. So let the entire surface be divided into large number of square loops. Let the area enclosed by the each infinite small loop be ds. Suppose n cap be a unit positive outwards normal to ds. The vector area of the element is. So it is flowing in a clockwise direction. We are able to find out. So this is where you can find the dr, that is a force, the force which is coming out. So we know that the curl of a vector field. Why I'm talking about force? See, the energy can be transmitted this way, that way, anyway. So if a light is falling and hitting an electron, means the electron can be vibrate and transmit energy this way, this way, this way, this way. All the ways, no? All the ways it can be transmitted. It does not mean that it only flows in this way. I'm talking about the flux. It might be in the line. The lines might be flowing in the straight. But the energy can be transmitted in the whole circle, no? It can flow all the directions.
Okay.
Okay, to find out if all the directions I can't find. So what I'm simplifying, I'm finding for the one single direction. Clear? So I'm able to find for one single direction. Then I can find for the n number of different directions. So to simplify that, what I'm taking surface integral of curl A dot dx, where it can find the line integral of A around the boundary of that area of the dx. Okay. So here, finding out the surface integral of A, from it is clear that the line integral along the common side of the continuous element mutually cancel because they transverse the opposite direction. The sides of the elements which lie on the periphery of the surface, that is closed curve, contributes to the line integral. The sum of the line integral of the boundary line of the curve is given by the equation. That is, surface integral of A dot here is nothing but surface integral of the curl of A dot here. That is equal to surface integral of x comma A dot ds. See, in unified physics also, in BSc level, you have this. That is simplified mode. That's very easy. Okay, if possible, I will share you in the next class. Okay, this is known as the Stokes theorem. Next will be the Gauss divergence theorem. Simple. Here we are in the Gauss, we are taking the volume. Volume, and we are finding the divergence of A dV, that is fluxes of A dot N. The lines are flowing now. Here the diagram they have not given the fluxes. In the textbook it is there. I'll show you how this surface integral with the volume integral we are finding. So now I am finding in the what is this? This Stokes theorem I am able to find for one single area and finding the line integral using a surface integral. Now in Gauss divergence theorem, I am taking a surface integral with a volume integral and able to find the different fluxes of the whole volume. So that will be the volume integral divergence A dot D. So this will be the equation. If you have any doubts, I'll help you out in the next one because time is over. So what we are finding? Surface integral A dot N of ds is nothing but volume integral of del dot A dot D will be the divergence of Gauss theorem. Okay. Stokes and Gauss will be the essay question. You just to simplify it, volume means triple integral, surface is double integral, line integral will be the single integral. So with this, your unit 1 is done. Okay. Create a group. Okay. Create a group. Add me. If anything is there, I'll share you in the group. Somebody take the initiative. All your members add in that group. And if anything which is not so easy in this, which is easy in some other textbook, I'll share you. So you can read from that. Okay? Clear?
Do you have
Any-
any question, study material, question and answers? Kind
Yeah,
of.
see,
You
this is
prepare
fine.
something?
See, this is text. This material is fine. But sometimes it is little bit complicated, I feel. So
Yes,
what
ma'am.
I do, I'll share you. You create a group and add me in that group in the next class. I'll share you.
Okay, ma'am.
Okay? Okay, then see you on the next class.
Mhm.